Jai Hind, Robert. Good evening, Ruchita. Jai Hind, Rudraksh. Good evening, Danpal, Sumit, Nishita, Deep, Hussain, Gandhiji. I am fine. Sushil, how are you? Nice. So, right. So let's start the session. Chaitanya, Sadbhavana, good evening. Okay. Quiz. You want any doubt in quiz? Two questions are wrong in quiz. I will discuss it today end of the class. Just remind me. What is that in the quiz? Number of, I think tomorrow is a doubt session. Tomorrow or day after tomorrow? For comparator equal to 4. I have given 5. That is wrong. Okay, this is corrections. Number of off adders for BCD edition. This is 11. Aditya, you should ask me yesterday. Otherwise, in the doubt session or end of the class, we can discuss. End of the class, remind me. I can help you. Don't worry. Or in the doubt sessions also, you can ask. Abhinay, good evening. Vasista, good evening. So let's start. So yesterday we have discussed SAR, but not problems. No? Problems are not discussed. So let's do it. Okay. I am not sure, Amitabh ji, if Namaste, Robert. If this part is completed, all problems are completed, maybe I will start the introduction of the logic families also. Then electrical people can leave. Don't worry, just wait. Let's start first this part. Yeah, no need on that. But I am not sure today it will start. We have lot of things to. I mean, more number of problems are there to do. Yeah, for ESC also it is not required. For double E. State PSU, I don't know because so many states are there, Rohit. Today, not only problems. Which branch you are from, Gandhiji? I don't think it's a better start. Try to listen. If you feel comfortable, you can. See, Aman or whatever, whoever asking me, any class, you clear the doubts of that particular class in that class only. If you have doubts of previous classes, use your doubt discussion class, or you can use groups. Don't bring that in this class, then it will be delayed like anything. What you are doing when I'm discussing that in that particular class? Every time I'm asking you to ask, n number of times I'm saying. Anuj, all general discussions, let's start the subject, then we can discuss about that. Yes, Asif. So because it is my weakness, I cannot move forward unless I clear the doubt. So let me clear the doubt of Aman. Just people will wait for 2 minutes. Okay. Then we can start the new things. So Aman, your doubt, how it is n plus 2? It is n clocks. This +2 is for SOC and EOC. Start of the conversion, you should consider it as one clock. End of the conversion, you should consider it as another clock. If you consider, you take it as n+2. Generally, n is the right answer. Perfectly right answer is n only. If n not available in the options, n+2, you can take it in that case only. Aman, clear your doubt? That is not required for you, Rohit. That is for instrumentation people. Okay. Let's start problems on. Aditya doubt is not cleared. Aditya, wait, we'll discuss at the end of the class. Don't worry. Problems on SAR. So abhi start karega. First, let me take the question. Right. Okay, your question is ready. Don't worry, I will zoom. This is the start of the conversion. This is end of the conversion. SOC, EOC. SOC. Is it okay? I will start the poll. Get ready, guys. Is it okay? Visibility is good. You have a 4-bit SAR type ADC, full scale output value of 15. The sequence of the states the SAR will traverse for the conversion of an input of 8.15. Your input is 8.15. What are the sequence of the inputs? Poll start karna. Okay. Right. Let's start the poll. Good. Very nice. 60%, 62%. Manohar, Rahul, Robert, Aishwarya, Anuj, Deep, Suraj, done. So here is the top 10. You can see Harsh, very good man. How you are managing every time first. Amitabh ji and also Aman. See, all of them, Amitabh and Harsh, both of them same time, but the app likes Harsh only. Even his name starts with A. I don't know why the app likes you much. Aman, Mohan, Abhinav, Deepak, Gandhi, Aditya, Sushil and Ruchita. नहीं दोनों का टाइम तो सेम है ना अमिताभ 0.9 seconds ही आया very good so let's do it 8.15 okay so let's do the question your what is the reference voltage here 15 15 is the reference voltage no it is same because both of them given one reference is 15 n equal to 4. What is the resolution? 15 by 2 power n minus 1. 15 by 2 power 4 minus 1, which will give you 1. Okay. So the resolution here will be 1 volt. We start with 1 followed by all zeros, which is 8 volts. So here my input is how much? 8.15. 8.15 is more than 8. So 8, sorry. So it will go down. Yesterday class discussion, 8.15 is more than 8. So it will retain that previous set bit and it will make the next bit also 1. In that case, you get 12 volts as the VD. But your input is now 8.15 is less than 12. So what it will do? It will reset the previously set bit and set the next bit. The story will be repeated. Now it is 10 volts. Again 8.15 is less than 10 also. So it will may reset that bit also, set the next bit. 1001 is 9 volts. Then it will reset 8.15 is less than or equal to 9 also. It will reset that bit also. Finally, the answer is 1, 2. So the sequence is this 8, 12, 10, 9, 8. So 8, 10, 12, 10, 9, 8. So option. Not assumed. He has given, we should calculate. I swear, please see. Difference voltage is given now, full scale output. 4 bits are given. From that, we have calculated VD. Resolution is calculated. VD is equal to resolution into decimal equivalent. Good. So I hope everybody it is clear. Shall we move further to the next question? Guys, are you ready? Any doubt? Ask me. Any doubt? Ask me. अमिताभ का doubt क्या? Sir, here what is the role of resolution? There is a role now. If without resolution, how can you calculate this to 8 volts and 12 volts? It need not be every time 8 and 12. If resolution is 0.5, we should take it as 4 volts. Okay. Resolution is having its role. Good. Clear? आगे चलेगा. So नया क्वेश्चन लेता. New question. Next question. Read that. A 4-bit SAR type ADC has an input range from 0 to 12. The output V1 next to the LSB is stuck at 0 fault. The pair of input that produces the same output for code word is. Same output code word is. Are you ready, guys? Shall we start the poll? Okay, I will wait. Right, start the poll. What is that wow factor here? Only 5%. Even your leaderboard also not updated. It got some anger on you. It is not happy with your performance. क्या हुआ? Okay, so let's see. First, let me prove my answer is correct. Then I will prove your answer is wrong. Both the cases. Okay. So first, let me prove my answer is correct. Okay. Because those many wrongs came, maybe my options are wrong. Let's check it. Let's try. So 2 volts and 4 volts. So first, for example, your input is 2 only. Input equal to 2. If input equal to 2, here also same resolution is equal to 15 by 2 to the power of 4, 15 volts, 4 bits, 2 to the power of 4, 1. Input equal to 2 volts. Then what happens? 1,000,8 volts. 1,000,8 volts. Now input is more or less than 8. Input is less than 8 because input is 2, which is less than 8 volts. So you don't ever take it as a binary conversion. It is always R into D. Luckily, in all our questions, they have given R as 1. It need not be written. So it will reset this bit, set the next bit. Here, how much it is? 4 volts. Still, my 2 is less than 8. It should reset this bit and it should set the next bit. But the problem is, what is the problem here? The bit 1 next to LSB is stuck at 0. This fellow don't want to become 0. He will stuck at 0. What is the meaning of 0? It is 0 volts. Now your input is greater than 0. 2 is greater than 0. Then what happens? It will keep that bit as it is, set the next bit. Then, okay, 1, 2, 3, 4 states. Now, what is this? 1 volt. So, now input is 2 greater than 1 also. So, it will keep it 0, 0, 0, 1. Retain it as it is. Just wait, don't worry. All your doubts will be cleared one by one. Rohit, what's happening? You are not revising your notes or what? Without revision, your preparation will not be helpful. Yesterday class, what I told, my dear guys, please tell me, what is the starting point of the SAR? MSB equal to 1, remaining all equal to 0. Okay, this is the fundamental rule for SAR always. Okay, please revise, Rohit. You can do well because you are able to do all the questions, but revision is required. Jada time nahi, just before coming this class, 10 minutes you read that PDF sufficient, everybody. So now who is there? What is that? Let's see one by one questions. Lucky. Okay. Lucky is having input by 2. Where is input by 2? Input is 2, not input by 2. Okay, right. I have taken option A. I am proving that option A is correct. That is my intention. Okay. So I started with option A. I assume input equal to 2. Okay, Udit. Next. Third one, how one erased. You have studied, read the question, not erased. See, the output bit B1 next to LSB. This is B1 next to LSB stuck at 0. This fellow will not become 1. It is always 0 only. That is the meaning of the question itself. We have this is your VA, this is your VD. Now tell me, if VA is less than VD, what you do? It will reset this bit and set the next bit. That is the rule every time. Here or here or here. Tell me, Deep, what is your doubt? Stacked 0 is different, don't care is different. Don't care means it can be anything. Stacked 0 is it is always 0. How both are different? Both are different as if stuck at 0. What does it mean? Stuck at 0 means that fellow is stuck at 0. Stuck in digital class. You are in the digital class, not moving to other classes. Similarly, here stuck at 0. You are stuck in 0. This fellow is stuck in 0. This fellow stuck at 0 only. Actually, after this step, next bit should become 1. But this fellow is not allowing. It is stuck at 0 due to some problem. It is like grounded. It is unfortunately connected to ground. He is having some cross connection with ground. He is having some illegal connection with ground. Yeah, it cannot become 1-0. See here, this is the star SOC. It is the start. After this, 4 steps. 1, 2, 3, 4. N number of bits. After this, you get n steps. I don't know all those things, Asif. Okay. Don't worry. I will check all your options. Don't worry. First, let me prove 2 and 4 are correct. Then you whatever options you want, I can prove it. Okay, if I get 2 answers, we can take 2 answers, nothing wrong. So firstly, everybody, is this process clear for the first case? For input equal to 2, is it clear or not? Right. Now let me take input equal to 4 also. Let me take input equal to 4 also. 4 less than or equal to 8. Starting point is same. 4 less than or equal to 8. 4 is less than or equal to 4 also. Then 4 is greater than 0. 2 is not happening now. If 2 happens, it may go to 3. That is different case. Okay. Yeah, not like it is. We are doing the same thing. There is no alternative other than us checking the options. So 4 greater than 0, 4 greater than 1. You get it will traverse to the same stages and come. For 4 and 2, your answer will be same. So it is proved for this. So anyone having doubt in any other option, tell me, I will prove that. Which option someone having that? If your input is 6, what happens? 1 and 2. If your input is 1, okay. Input is 1, you want to just wait, just wait. If input is 1, what happens? Let me prove it. Then I will check the other options also. If input is 1, 1 less than 8, 1 less than 4, 1 is greater than 0. But here, 1 is not greater than 1. Na? It will be 1 less than or equal to 1. You get all zeros. Verify is better. You cannot check for all the inputs now, because here question is also to verify these inputs only, not every input. Here you have different inputs possible. In 0 to 15, you can use infinite inputs. 0.3 is possible. 4.9 is possible. If you don't want to check options, you check all these inputs. Examiner is so kind. He kept the answer in A only. But if you are not lucky enough, you may start from D. Then if you are more intelligent than examiner, then you may think A may not be answer. So start from D and C, B, and then you may come to A. Okay. So now who is asking that for 1 and 2 answers are different? Accepted or not? Arey yaar, wait karo. First point, whatever I ask, tell me that first. Right, it is proved, and 4 and 6, let's take it. If you get same, no problem. So input is what? Some people are very much interested for input equal to 6. Let's check it. What is there here? 6 is less than or equal to 8. First step same, but 6 is greater than 4. 6 is greater than 4, so it will not go to this path, it will go down. If it comes down, then it is 6 is greater than 4. Now it will keep that bit as it is and set the next bit. But unfortunately, 1 minute. Unfortunately, you cannot set this bit. This fellow will become 0 only. Story to same, na? Understand this point or not? Input is 6. 6 less than 8. Correct. Okay, come here. 6 greater than 4. So it will keep the previously set bit as it is and set the next bit, but it cannot do it. So it will stuck at 4 here. Now input greater than 6 greater than 4. So what it will do? It will keep that and set the next bit. Again, input is greater than 6 is greater than 5 also. So it will stuck. Finally, you get this answer. Why same here? You get 5 here. For 4, you are getting 1. How they are same? So why you like this option very much? I don't know. If you do like that, so many options will match. Don't do this. This is the wrong way to do this question. If the examiner is not a fool. Okay, in that case, binary conversion may sir 6 and 4 may what is the same sir? Don't do that. Okay, that will trouble you. Shall we go to the next question? So 5% right answers for this question. Very less. Okay, Arisha, if that is the case, I don't give this question now. So let's start the next question. Try this. Yeah, I also have same doubt with it. But if I ask, people may think even I don't know that also. That's why I'm saying. Oh, sad means sad. Then if it is bad life, you call bad life. Bad time, bad time. Okay. So let's start. So 8-bit unipolar ADC, some story is given, 3.5 reference voltage is 5 volts. Yes, and now the output of the ADC after the third clock after the start of the conversion. Surya is absent today. He is there yesterday. I don't know. Today he is not present. Today is his birthday. Yesterday also he celebrated, I think. Is it real birthday? Then happy birthday, Subra. Maybe he will watch recorded. Okay, so let's start this question. Hmm. By this only. So we start with 1 followed by all zeros. Where we start? 1 followed by all zeros. 1, 2, 3, 4. Okay, listen here. Please listen. So what is the resolution here is input is 5 by 2 to the power of 8 minus 1. 5 by 255. Every time it is not 1 volt. Resolution is this much. Then what is VD here? Resolution is 5 by 255 into decimal equivalent. What is the decimal equivalent? 128. Please stop that. Now tell me the values. Please do the calculation. Good boy. Let me do it. 5 into 128 by, I will give you shortcut way also. So 2.5098. 2.509. Now your input is 3 point how much 5? So 3.5. So input is 3.5 is greater than this 2.509. Then what you do? It will keep that pre-bit as it is. The next bit also made equal to 1. Sometimes examiner asks you to draw this waveform. 8, 12, like this. You can draw this output waveform also. Okay. So now this is the value. But for this value, what is VD? 196 into resolution 5 by 255. Yeah, 3.764. But my input is 3 point how much? 5 less than 3.76. So it will reset that recent bit and set the next bit. Okay, examiner has asked only up to this. Why up to this only, sir? Listen. Here, what is the value you will get it if you want here? Asif, what happened? 196 into 5 by 255. 3.843. Who is that who told 3.76? Who spoiled this? Alcha Max or Min? 3.843. Okay. So examiner asked up to this, so we stop here itself. Here what if you want you can calculate. It is 192. 128 64. Why 192 man? Abhinay? 128 and 64. 4 and 8 2. Right. I am wrong. Yes. This is 192. So here what is the answer? 128 plus 32. 160 into 5 by 255. Then what it will do? It will keep that bit as it is. Okay. And next bit will be made equal to 1. Why I am doing this? It is not required. Examiner asked 3 steps. Actual sense in this question, there is a wrong in the framing of the question. Why? Because the output of the ADC at the end of 3 clock pulses after start of conversion. Okay, so you may take this will happen immediately after the start of conversion. Then you may take this 1, 2, 3 as the answer in that case. Okay, 3 at the end of third clock after the start of conversion. After this 3 clocks, if you take, or start of the conversion after first clock, may if you assume this, second clock this, third clock this, then this is the answer. But examiner is kind enough, he has not given both the options. So you should go with examiner. You cannot argue with him. Here, without doing this calculation, shortcut is simple. Listen here. This will be approximately 5 by 2. Correct or not? Blind answer. Okay, because it is resolution half of this na around. Actually 5 by 2 plus step size will give you this answer. This will be how much it will be 5 by 2 plus 5 by 4 approximately. You check it 2.5, 1.25, 3.75. Understand the logic? Okay, if you add previous by 2 or previous by 2, you may add it or subtract it depending on whether you are increasing or decreasing. Okay, so this will be 3.75 minus 5 by 8. Not exact, approximate I'm saying. What is this? 2.5. So this is the shortcut way to do this problem instead of calculating that. You have also done like that? Approximate values will give you this. No, complete calculation is good, but approx also will give you the answers because there is no nearby answers in this case. That is, suppose if input is very close this value to this, suppose input is 3.755. In that case, you should doubt. I got 3.75 approximate. Maybe it may be in the border. You should take care. If input is little far from your this one, so need not worry much. Okay, no problem. So let's move to the next one. So now our favorite, the next ADC we are going to discuss is dual slope integrated. Both are same here. Whatever we discuss is same. Integrated. What is that? Type ADC. Dual slope integrator type ADC. This is the last OS. Whatever we have discussed is the same as what we call unipolar. Okay, examiner may you give it as unipolar or SAR, both the cases it is same. It is going in only one direction, na? Okay, same single polarity you can say. So let's start. So now the figure I will use it now. So this is what we call dual slope integrator type ADC. Okay. So this is in this, what are the parts? This is RC integrator. This one is technical name zero crossing detector. Okay, so what it will do is like this. It will give you 1 if V naught less than 0. It will give you 0 if V naught greater than or equal to 0, because 0 is positive, right? Positive is 0, so negative should be less than 0, then you get 1 here. Otherwise you will get 0. How it will work, don't worry, just understand part by part. RC integrator circuit, zero crossing detector, this EOC signal is end of conversion, we will discuss it. So here if it is 1, clock will be allowed. If it is 0, that is if your V naught is greater than or equal to 0, if V naught is a positive quantity, here you get 0. 0 into anything, what is the answer? 0. Okay. How this will work as a ADC, we will discuss it. Don't worry, just wait. Okay. Suppose see here. What is V naught? It is minus 1 by RC integral 0 to T current I. Sorry, what is current? Sorry. Your input V dt. RC integrator circuit. Na? So here it is minus VA by RC into T. Some 0 to say for example some integration time T. Will you accept this V naught equation? Okay. So it is a negative going slope signal. So this will be like this. It is a negative going slope signal. 3 examples I have taken. If input is more, for example, if I fix this time, for example, see here. If your time, suppose if we take time t equal to ti, what is your V naught? Minus VA by VA into TI by RC. Yes or no? Please tell me this. Okay. Now listen here. Now listen here. If how it will work, we'll discuss mathematically. I will prove it. Just wait for some time. If TI is fixed, I have fixed TI. Can I say this value is proportional? RC also fixed. This TI and RC fixed. So this V naught value will be proportional to, okay, TI is some fixed value. Okay, some n number of clock pulses or 2 power n number of clock pulses. It is some constant. Okay, it is the time duration for which you do this integration. What is T here? It is the time duration for which you do this integration. Okay, so assume that is a fixed quantity. Say you take this as 2 power n clock. What is this? Ti is a fixed quantity, 2 power n clock. Now what I am saying is if Ti fixed, RC fixed, Va is more, then V naught will be more. So see here, if my Va is a big value, I get more V naught. Okay. If Va is a little less, you may get less value. If it is further less, it may get less value. Now please listen here. You have a switch at the input. Initially it is at Va. When it is at Va, it is minus 1 by RC integral I dt something Va dt. You get this value. Okay, negative slope, negative minus, because it is minus, you got it as a negative slope. Okay, because it is a negative inverting amplifier. Okay. Suppose you connect after TI, you connect this switch. Firstly, assume manually you move this switch from here to here. Then reference voltage is there here, which is negative quantity. Assume you have a reference voltage which is negative quantity. Then what is V naught for the next case? What is V naught? It is, listen here. I'm sorry. Into what V naught 1, you do this integration. Until it reaches 0, I want to do the integration. Once it reaches 0, I will stop this integrator circuit completely. So first I connect to V in, second I connect to V reference. When I connect the V reference, it is having positive slope and reaches the origin. When I connect to V reference, it is having positive slope and reaches the origin. Now, very important point is, if input magnitude is more, it requires more time to get into 0. If input magnitude is less, it requires less time to reach 0. Accepted or not? Okay, wait. So say for example, at time t equal to, I'm giving this names. I will explain the names. Don't worry about it. So at t equal to tau, at time t equal to tau, okay, time t equal to capital, up to what time I will do is some tau. Some tau is, what is tau? I will tell you. Just tau is the time where it reaches 0. So what is your V naught? It will be equal to 0. It will be equal to V naught 1 plus V reference by RC into T from, okay, replace the T with, okay, tau. Then what is that? Tau minus Ti or Tx, Ty. You take any variable, doesn't matter. So can I say here, 0 equal to V naught 1, okay, this is V naught 1 plus V reference by RC into TD. V naught 1 plus V reference by RC into TD. What is TD, sir? TD is the time difference. This I gave the name as TD. What is TD? The time from here to here. I name it as TD. So you can say minus V01 equal to V reference by RC into TD. Okay. So what is V01 according to us? What is V01? Minus VA into TI by RC. So minus of minus plus VA into TI by RC equal to V reference into TD by RC. Here one important, very important observation we should have is this RC cancels. Sir, both sides RC is there, they will cancel anyway. What is the important observation we should have is this is the thing. If same, because of same resistor capacitor is used when it is integrating and deintegrating, because of this component values, or you can say component stability, will not have much effect in your accuracy. Whatever the effect due to the tolerance of the resistance or leakage of the capacitance will be nullified, because we are using the same components for both the cases here. That's why it will be most accurate without depending on the component stability. Because you understand here, charging and discharging, I am using same resistor and capacitor now. Because of this, what happens, if there is any deviation, that deviation will be nullified. If it requires expected, you are expecting this, you got something this whatever you are getting this, that will be nullified during the discharging time. Okay, so that's why this dual slope ADC, without depending much on the component stability, depending much on the component stability, it will give you better accuracy. You understand? Now let's solve this equation further. VA into, what is VA, sir? Analog input equal to V reference into TD. What is TD? VA into TI by V reference. You can also write V in into Okay. Isme, I already told you Ti is a constant forever in any system. I mean, in this particular system. V reference is also constant. If these are in our hand only, Ti and V reference are constants. Then can I say Td? What is Td? Is proportional to V. How it will work? Just leave for some time. Firstly, tell me this logic is correct or not. I'm repeating the logic. Listen here. First, forget about the whole circuit. This fellows connect the switch here. I will get the V naught is equal to minus 1 by RC integral V dt. Okay. So minus VA by RC integration of constant is T 0 to Ti. What is the Ti? I fix it as 2 power n clock pulses. What is Ti? 2 power n clock pulses. I fix Ti is equal to 2 power n clock pulses. It is a fixed quantity. Happy birthday, Soraji. So now at time t equal to Ti, at time t equal to Ti, no problem. At time t equal to Ti, what is V naught? Just substitute t equal to Ti, V naught equal to minus Va by Ti into RC. I took this as initial voltage. I took this as initial voltage V naught. Okay. So, okay, celebrate. I will wait. Oh, you call him Baba? Okay, fine. So let's start. Let's go back. So see here up to this is your V naught, which is equal to minus VATI by RC. Now listen here. What is V naught? It is now this is during integration. Now what I will do after this time, I move this switch from here to here, which is a negative quantity. So this is during deintegration. So during deintegration, what I will do? This is during deintegration. Your capacitor is having some initial voltage. Now minus 1 by RC integral Ti to some tau. I will integrate it. What is the value of the reference voltage is negative now into dt. Negative of negative will give you positive slope now. So what I will do is I will prove all those things. I will design my circuit such that it will stop after once it reaches zero. That time I am taking as a tau. This time difference I am giving the name Td. So at time t equal to tau, your V naught must be equal to 0. Okay, so I will design like this. See here. Okay, so this is I fix it as Ti, which is 2 power n clock. Okay, so now after Ti, what I will do? For few minutes, please don't talk. Listen here. It is up to tau. Okay, this time gap I keep the name TD. Up to what time I will do the deintegration? This is the time of deintegration, and this is the time for integration. This is your V naught. That is your voltage is varied like this. Okay, this is during integration, this is during deintegration. Is the name we kept it here. Okay, so once it reaches the origin, I will stop it. How I will stop everything we will discuss it now. So what I am want to prove is at time t equal to tau it is 0. When you make this equation equal, what is the final condition we made or we proved is your time required for deintegration is proportional to the magnitude of the input. So if I use one counter to count during this deintegration, then I can say my counter output is also proportional to the magnitude of the input. That is how I can do a analog to digital conversion here. I will run a counter during this period. During this period, I will run one counter. Then my counter output will be proportional to magnitude of the input. Because it is proportional to this, my counter output is proportional to TD, and where TD is proportional to the input. Now see here, different inputs will take different TDs. So your TD is proportional to input magnitude. Your counter output should also be proportional to input magnitude. Now let's see how to design the hardware for this. Now see, first part we'll do the integration part. Then see here, your count. Firstly, what I will do, I will allow the counter to count from all zeros to all ones. It will count from all zeros to all ones. After all ones, what it will do? After all ones, it will become all zeros again. Once it becomes 0, that is 2 power n clock pulses. You understand? Once it becomes 0, it is a negative going edge. This negative going edge will be given to the negative edge triggered toggle flip flop, which will be toggled at the negative edge. Okay, that toggling can be converted into mechanical form or some electrical circuit will be used so that the switch will be moved from VA to V reference. So initially the switch will be at VA, it will be integrated up to 0, all zeros to all ones. Whenever it changes from 1 to 0, whenever it changes from 1 to 0, then what happens? This will make one circuitry such that the switch will be moved from this position to this position, VA to V reference, which is a negative quantity now. Now the counter starts fresh. Yes or no? Now the counter starts fresh. Starts from all zeros. The counter will start from all zeros now. Okay. So how much time I allow the counter? As long as it reaches origin. As long as it reaches origin. How, sir? Listen. See carefully. See carefully. If this value is negative, if this value is negative, V naught is negative quantity, then you will get 1 here and clock will be allowed here. Okay. So you understand, if this value is, if V naught, as long as V naught is negative, okay, you will be getting 1 and the clock will be allowed to the counter. Once this value reaches origin, once this V naught reaches origin, once this V naught reaches origin, what you will get? When V naught greater than or equal to 0, this 0 crossing. That's why the name is 0 crossing detector. It is a comparator only. Once this value will reach 0, then you will get 0 in the output. If it is a positive quantity, once you are integrating, once it crosses 0, it will give you 0 here. 0 into anything is 0. Counter will stop counting. So dual slope, why it is called dual slope? It is having 2 slopes. Okay, so the counter will be allowed to count 2 times. First it will count for integration of the input, all zeros to all ones. Then it will be moved from 1 1 1 1 to 0 0 0 0. Then what happens? This flip flop will change this circuitry from here to here. Then again the counter is allowed to count, but until it reaches origin. Once it reaches origin, if this V naught is greater than or equal to 0, if V naught is greater than or equal to 0, then what happens? This comparator will give 0 in the output. If it is 0, then clock will be stopped to the counter. Then I can understand conversion is completed. I will get here signal also, because when it is 0, you get end of the conversion signal. Then I may use some switch externally to discharge this capacitor, and I will start the system freshly for the next conversion. So here, what is the final rule? Here, RC value can be anything. It will, I mean, some deviations in the RC will not affect your accuracy. And also, your TD is proportional to Vn, so counter output is proportional to the magnitude of the input. I didn't get you, Rohit. What is your doubt? What is your doubt, Sushil and Rohit? Please ask. Output counter will show us. Yes. This is the digital output we are taking, counter output only. But when you take, when conversion is completed, not in between. In these cases, what to do? In between, you should not take it. You should use this signal such that when EOC equal to 0, then you can say conversion is completed. You should take the final. Is it clear, Rohit? Okay, fine. So all your doubts are clear for this circuit, how it will work, everything. Any doubt, please ask. Initially, we give SOC, it will clear flip-flop, everything. Then start fresh. You can discharge here by using some switch. Oh, here the name is V reference. It is not full-scale output. Here your output is digital, man. How you take it as a full-scale output? Your output is ones and zeros only. Okay, Sushil, don't worry, wait. Aditya, your output is ones and zeros. When you have DAC, then only that reference concept come. Here there is no DAC. In this circuit, we don't use DAC to compare. Yes, Aman, in charging it comes to all ones, then all ones to 0, then it will come to second part. Zero crossing detector, concentrate here. Suppose here if it is -1, tell me, Sushil, if it is -1, this is 0. What is the output of the comparator? No, see, comparator, okay, positive is having more value compared to -1, negative. -1 is less compared to 0 now. I didn't understand. What do you mean by V reference, Aditya? V reference is the full scale output for DAC. This is some fixed value. You take 10 volts, 5 volts, 8 volts, anything. According to your magnitude of the input. Okay. So according to the capability of the system, you fix this value. You may fix it. So you should do this calculation, but accordingly, okay, we will fix the value. It can be any value, it doesn't matter. This V reference will decide this TDTA ratios and all. V reference by V in will give you TI by TD. Okay. So any doubt now? Who is that? Sushil. Suppose if it is a +1, now what happens? Sushil, tell me. Now 0. Or if it is a 0.1, 0 is less than 0.1, 0. That is, once this value is greater than or equal to 0, you get 0 in the output. Then this 0 into clock will give you 0 for the counter. Counter will not count anything. As long as this is negative, you get 1 here. According to the clock, counter will count. Sushil, is it clear? Good. Any other having any kind of doubts, please ask me, then we can move to the problems. It depends. Okay, it can be less or more, doesn't matter. Accordingly, your TDTA will be decided. No, need not be. Ideally, please listen. In this example, I took 2 power n. For this case, TD should be less compared to TI. But some, depending on the design, actually our design requirement is it should be fixed. Okay, it should be fixed. In general, you can say counter will count from 0 to 2 power n minus 1, and it will After at 2 power n clock pulses, it changes. For this particular design, I can say TD is definitely less than TI, but not sure every time. Suppose if you fix the count to be 10 clocks, maybe TD more than that. Okay, TD TI ratio depends on this VA V reference ratio. Depending on these values, this ratio depends. We do the problem on that, don't worry. So if VOC is 1, then it will tell that output has arrived. Now EOC is 0, it will tell. It is, see here, zero crossing detector will give you 1 as long as the conversion is continued. Whenever it's 0, it will tell that conversion is completed. In this case, it is only up counter can give you the output proportional to the magnitude. You can design with down counter, then you need to do the extra circuitry. In counter type, you can use the up down counter for tracking type. Here, your output should be proportional to the magnitude. In that case, you need to use the up count. So, okay, fine. Any other questions? Then we can move the problems. Guys, tell me. Okay. So, read this question. Try this question. Yes, you don't want poll, Sushil? Okay, do the mathematical part. I will start the poll. Okay, start the poll. Poll gaya. So now, right, this is the reference voltage in this case. Direct substitution. I don't give much difficult question initially. V reference and the integration time Ti is equal to 300 milliseconds. Somebody asked me earlier, na, sir, TD can be more than. For examiner, it is more this case. We should not argue with it. Okay. So what is the input DVM indicating means? What is the input voltage? So Vin into Ti equal to V reference into TD. So what is the Vin formula is V reference into TD by Ti. So V reference is 100 into 370.2 by 300. So in this case, it will come out to be 123.4. calculation part you can do it, you will get this. Here, 3.5 digit means already I told what is the meaning of half digit and full digit. That is not required for this question, but you know the meaning. Okay, it can represent 0 or 1. So this is a straight away question, nothing difficult here. So now let me give you a few points. Yeah, data converters. I have one very good question. Don't worry. Not some more. Best question is there. Don't worry, people. Is coming. So before that, so a few points I have written so that you can understand better. So the dual slope integrated type ADC, the input is integrated for fixed amount of time, say 2 power n clock pulses. During this period of the RC integrator, V naught is negative and slope is also negative. I already told. During when the counter output changes to 0, then the switch is moved from input signal to V reference, which is negative. Now the counter starts fresh. Slope of V naught is positive. Okay. Zero crossing detector will allow the clock to the counter as long as V naught is less than 0. Every point I have discussed. Once it reaches 0, the clock input to the counter is 0 and the counter stops counting. The time required for deintegration, that is V naught to reach 0, is proportional to the magnitude of the input. So the counter output is proportional to the magnitude of the input. Everything is clear? These points are discussed in the class. It is the slowest ADC but most accurate ADC. Why it is slow? I will prove it. Since the time same RC is used for both integration and deintegration, if there is any deviation, it will be nullified. Dual slope type integration can eliminate the noise due to power supply. I will come to this point, okay, clearly with the problem. If the integration time is integer multiple of time period of the power supply. It is suitable for applications where speed is not important, but accuracy is important, like digital voltmeters. It is not suitable for applications like DAS because it requires more time. Why more time? Okay. Why more time? Because it is having two steps, integration and also deintegration. So we'll leave that, don't discuss. What is that? Right, correct. It is having both integration and deintegration. So let me calculate this time required for conversion. It contains integration time and also deintegration time. Okay, so the time required for conversion is for integration it is fixed not 2 power n clocks. For deintegration, what is the time? For deintegration, it is 2 power n minus 1 clock. Maximum. The counter can count maximum this much. It starts from all zeros, it can reach maximum 2 power n minus 1. Is it okay what I am saying? Counter deintegration cannot reach more than this. Okay. So what is the total time is 2 power n plus 1 clock. This is the maximum time. Lowest is 0. Lowest is here it may be 1. Count integration time is fixed. Okay. So counter may stop after 1 clock depending on the input we have provided. Okay. So generally if nothing is specified also what we calculate is called as worst case delay only. So this is the slowest ADC. Why slowest? Let's do the comparison. Let's take one table. So let's make this table. So DAC, the time for conversion. First, what we have discussed, counter or single slope. Okay, then flash, then SAR, then dual slope. The counter conversion time is 2 to the power of n. Okay, worst case. Here flash only 0 clocks. Here n clocks. Here 2 to the power of n plus 1. You can take here 1 also, that I told already, don't worry. Here 2 power n minus 1 also is possible. Okay, this is the worst case delays in any what we call counter type, flash type, and also this one is the fastest, slowest, most accurate, and here what is the advantage? Uniform conversion time. So what is your doubt, people? Please tell me. Excuse me. Any doubt? Yes. Compared to 2 power n, that's why I kept this symbol now. Approximation. Powers of n we speak generally for a delay. Compared to that, you can neglect that small one. And we are back. Okay, we are back. Stop your discussion chatting. Power gone. Right. So compared to exactly, if you want, this is 2 power n plus 1 minus 1 clock. Okay. Right. Accuracy one, which is best one, is this one only. Okay. Here one see here. Here one disadvantage is what is the disadvantage here? What is the disadvantage here? More hardware is required. Okay, here more hardware is required. Like that, according to the design. Okay, different. In these two cases, your accuracy depends on the DAC. In the feedback there is a DAC. Each step size will decide, and your component values also. You can make TD equal to 0 when your input is 0, man. Rohit. If your input is 0, your TD can be 0. Okay, if input is very less, then it is possible. Okay, if it is not integrating anything, then your counter may not move further. Right, let's start the good questions now. You are ready, guys? Okay, challenge. One easy question, one tough question is getting loaded. Level 2. So let's go by sequence. Sushil. This question, everybody, I think I'm expecting 100% from this question. I am expecting 100% from this question. Let's try. Give a try, man. It is easy question only. What happened? Mohan, refresh. Refresh. Question is loaded already. Any issue? Remaining people, please tell. No issue, na? So you have a dual slope integrator with the reference voltage 100 millivolts. The first integration time is 50. The input resistor input resistor of the integration is 100k. Capacitor is given value. What is for the input voltage of 120? The second integration time will be how much? Very simple, straight away question. So let me start the poll. Wait. First, it is the easiest question. ये तो finally you beat deep equal to what is the formula? Mean into 200. So now do this. Okay, done. It's a simple question. So now do this. Do this. Okay. So read the question. In a dual slope ADC, the reference voltage is 100 millivolts. The first integration time, everything is given same story. Okay. Now this is the second part of the question. If the input is 120 millivolts is corrected by a power supply interference of 50 Hz, having the peak amplitude of 3 pi millivolt. The worst case error introduced by the interference in the reading is. So start the poll. Okay, try. Wait. I will wait. Take it. Take your time. एरर इन द रीडिंग आसिफ रीडिंग में क्या हमको वोल्टेज आएगा ना Okay, so let's start the poll. Good. Nice. 40% right answer. I'm happy. So Mohan Sai Gandhi, today you came and entered into the top. Very good. Gandhiji, Aditya, Asif, Deep, Amitabh, Harsh, Ruchita, Anupama, and Vasista. Right, very good. So, Aditya, today you are in the top, man. Mohan, Asif, Deep, Amitabh. Good. So, let's do this question. Let's do this question. Here, one important point here is I told this in this here. In the dual slope, it can eliminate noise due to power supply if the integration time is integer multiple of time period of power supply. Okay, what is the meaning of that? I will show you now. Here, RC values are no use. Believe me, I have seen earlier. This question is a previous gate question in one, I think, instrumentation somewhere. So if I see the solutions, no single publication has given right answer. Answer to diya, explanation is not given. Okay, they used this R and C, they managed, they manipulated, they got some answer finally. Okay, so in the textbook also I am not able to find it. Somehow from some NPTEL lecture I got some point, based on that I got how to do the question finally. So now I will share with you. See, firstly, what is your TI? 50 milliseconds. Okay, so listen here. The input 120 volts. Input means integration time only, na? Input is integration time only. Yes, Aditya, but long back, 3 years back. Input is 120 millivolts. Okay, now, no. भगवान एक होता है, we are just followers. Okay, let's do it. TI is 50 milliseconds. Then input. What is your input? 120. Okay. Now, what is the frequency of power supply? 50. What is the time period? 1 by 50. It is 20 milliseconds. Okay. So now, what is TI is equal to 2.5 times T. Thank you for your love. So can I say 2.5 into 20 is 50? Is it integer or no? It is not integer. It is not an integer. Okay, so leave this. Leave this in the sense, if it is integer, answer is 0. If it is integer, answer is 0 blindly. Now I need to give you little network knowledge here. Okay. Anyway, we are starting from the August 3rd, but before that, I want to share some basics of the networks, because for this question it is required. You have something like this. Okay, this is pi, 2 pi, 3 pi, and so on. What is the average value of this signal? 2Vm by pi. I hope you know it. Very good, Alj. There is another signal called half rectifier. Pi, 2 pi, 3 pi, and so on. Okay. Here, what is your average value? 2Vm by 2 pi. Why 2 pi, sir? Here time period is pi, or your repetition is pi here. Here repetition is after every 2 pi. So answer will be 2Vm by pi. And now let me convince you this one. It is pi, 2 pi, 3 pi, 4 pi, for 5 pi, again it started. Okay, 2 Vm pi, Vm by pi. Okay, okay, don't. In this case, very good. So you got my point. It is 2 Vm by 5 pi. That's all. This is the basic you need before going to this problem. 0 quantity. Okay. So now, what is the question? You have some voltage V in millivolts, 120 millivolts. Okay. So for this input, there is a noise of how much? Say you take time is equal to here 10, 20, 30, 40, 50 milliseconds. Because your integration time is how much? 50 milliseconds. 40, 30, and 20, 10. So this is your input, which is a constant of 120 millivolts. That is integrated for how much time? 50 milliseconds. Now see here. Now see here. For that, there is a input is corrected by power supply noise of interference of how much? 50 Hz. 50 Hz power supply, which is having a time period of 20 milliseconds with magnitude how much? 3 pi millivolts. So now for this signal, don't scale it, but it is you take it as a pi, 2 pi, 3 pi, omega, okay, 4 pi and 5 pi, okay, because one time period is equal to 20 milliseconds, okay, that is a 2 pi angle, okay. So इसमें you add small 3 millivolt. What is that? 3 pi millivolts. What is this height? It is 3 pi millivolt, okay. So and this one, so this one and this. This is what happens during the integration period. During the integration period, this fellow power supply noise came and it has oscillated like this. So one advantage of this sine wave is positive half, negative half cancels. Positive, negative cancels. By chance, if your luck is good, if you have this also, average value will be 0. Noise influence will be automatically cancelled. That is what I told you. Dual slope integrator, if the noise due to power supply can be eliminated if integration time, okay, is integer multiple of time period of the power supply. If you have integer multiple n number of time periods, no problem, positive, negative, positive, negative, positive, negative cancels. But here you got 2.5 cycles. So if it is 2 cycles, okay, 3 cycles, okay. In the because of this 0.5 cycles, you get some average value. What is that average value? Otherwise, average value is 0. For a full sine wave, positive, negative cancel with each other. What is the average value of this part? 0. So if you integrate, this part will be equal to 0. So only this is left. So what is the average? Everybody comment now. What is this height? 3 pi millivolt. 2 Vm by how much? Out of 5 pi. Please understand, out of 5 pi, it is only one. You assume like that. Like this example. Out of the 5 pi, it is only one time. So can I say it is 2 Vm by 5 pi? Good. Very good. So 2 times 3 pi by 5 pi. So 6 by 5 will give you 1.2 millivolts. Not peak to peak. He said only peak. Right. So please listen here. What is the error percentage? measured minus expected by measured into 100%. So 121.2, because 120 plus 1.2 average is added, minus 1.2 by 120 into 100%, which is 1%. Because of the noise, your measured value may be varied by 1%. Okay. Yeah. Measured minus expected is 120 by expect. 1 minute, I'm sorry, gave the wrong formula. Measured minus expected by expected into 100%. Why 4 pi, man? It is total 5 pi na. You assume this is the signal simply. Forget positive negative. Okay, because it is cancelling with each other. Clear, everybody? Happy? Thank you, people. Second time, what is that second time period? First time period, second time period. Okay, Asif, what is your doubt? From 5 pi to 10 pi, why are you worrying about 5 pi to 10 pi? Your job is done by 50 milliseconds only. After that, what happens is not required. If I say 100 milliseconds, then that positive negative cancels. Then in that case, you will get 0. But you integrated only for 50. That is the problem. If you integrate up to 100 milliseconds, then this noise will be gone. Okay, because this noise is added during the integration time. Okay, because when input is applied, we took it as a integration. Thank you, Asif. Okay, so that's why to make the analysis easy, I gave this example. Okay, so that's all. Few more questions are there. Let's do it. Let's crack it. So today I'm not going to start what we wait. I need to give you some announcement. What is that for electrical guys? We need to talk sometime. Double E, next tomorrow there is a logic family class, right? 1 minute, 1 minute. I will check my schedule. Educator. Today is 21st. Tomorrow logic family is okay. 23, 24. So 25th we will start microprocessor. Okay. Logic families on tomorrow is what? 22, 23, 24. 23 is doubt session. If you have doubts, you can come there. This is only for EC. Okay. This is for both EC and E. Any instrumentation people are there, they can also come. So आपको 2 दिन और 3 दिन छुट्टी मिला, right? Udit. But now I will upload 125 questions something. In that, if you have doubts, you should come on the doubt section. No, for ESC also it is not there. They have removed. Most of them are W only. What about 23, sir? That's what I told. Na 23 May I will upload now some questionnaire that will be discussed. If you are instrumentation, you need to study. Or in the what we call in your analog, it may come. Okay. So this is the schedule about it. Everybody, it is clear. Now come back. So see here. So let's start rapidly poll and do some good questions. Shall we do? These are easy questions only. Okay. Let's. So what is doubt? I have not seen his doubt. I already, I think, answered Abhinay. Thank you, Lucky. Abhinay doubt is already answered. Not required. If you are not instrumentation, don't worry about it. I'm not sure about in your analog part if it comes. Okay, analog sir will take. For from digital point of view, not okay. So let's start the poll. 100. What happened here? Not 100 is not coming. Yes, come and enjoy. You are always welcome. So you can see why some people gave wrong answer for this. It is the easiest question. What happened to Harsh? He left the class or what? Thank you, Asif. Poll is not showing. Oh, no problem. So it is a simple question. It is a SAR. SAR may what is the answer? The conversion time for the input of 2 is what is the answer? It is independent of magnitude. It is same. Very good. This is already done. This also done, na? This is done. This is done. Okay, done. I I think this. So these are already discussed. Okay, if you are new, please don't think I'm just ticking and not discussing. But yeah, no new questions are there. Yes, start the poll. Let's start the DPP is not this one. DPP is also there. This is not done right. Let's do it. Poll started. Good. Good. So now see here, for flash type ADC is the fastest ADC, you know, everybody know it. Dual slope is the integrator type. So counter and SAR both uses DAC in the feedback, but maximum conversion time of N is only for SAR. Then counter should be for DAC. That's all. So this is 2, 3, 4, 1. Next, read that. Question is easy, so I'm not giving much time. What happened? Yeah, who is that? Who gave wrong answer here also? Which of the following type of ADC conversion time is practically independent of what happened, Aditya? Amplitude of the analog signal. Poll is not showing. Please help him, Gandhiko. Remaining students, why refresh it once? I have only that solution. So uniform conversion time independent, uniform conversion time is SAR. Next question. अच्छा टाइम भी हो गया. या टॉपिक तो एडीसी डीएससी का, इसलिए 60% आया क्या? अरे यार, this is discussed in counter spatial to temporal. What is that? Parallel input, serial output. It is done by shift register. As we are discussing data converters, your answer is not ADC and DAC. Right. So next question. No, 3% is there. Screenshot नहीं ले लिया. So the advantage is it is having not small conversion time. It is having high accuracy. Next. Read the question. A dual slope ADC uses n-bit counter. When input signal is being integrated, the counter is allowed to count up to which value? Very good. Strong. अरे यार, read the question properly, man. What's happening? ये तो 100 expect किया. Yes, it depends on question, Amitabh ji. These are easy questions. That's why I'm not giving. Okay, net issue is there. Right. So finally, Mohan, you are on top, man. So dual slope integration time. Here he is not asking reference voltage. Input is integrated for how much time? When the counter counts from 0 to 2 power n minus 1. After that, it will become all zeros. It is proportional to VA if it is V reference. That is during de-integration. It is here integration. Next, this is done. Let's start the Read it. I will give some time because some people are asking. Amitabh ji, please take your time. I will give few seconds. Some people are. Next, this is done. Let's start. Read it. I will give some time because some people are asking. Amitabh ji, please take your time. I will give few seconds. Don't walk on cake. Right without keeping extreme requirements on component stability because RC cancels. Good rejection to power supply that I told now. If it is integer multiple, if that integration time is okay, 4 is not what we call. See that there is no way you can prove that it is having better resolution. Resolution as step size here is not for same number of bits. It is having better resolution. This is not specified. Accuracy I told. Okay, what is that? Extreme means high requirement. I want high, I mean, less tolerance, best capacitor, best resistor. Okay, without giving such kind of extreme requirements on the component stability, it is performing well. Anyway, you need not doubt also because 234 is also not available in options. Okay, so resolution is based on your n only in general. Okay, when you increase the n, resistors are increasing or not, all those things will comes into picture. Number of bits, but bits are depending on what? Whether it is depending on your counter in the given circuit, all those things. Next, it depends. V range. It depends on the range also. That's it. Next, a dual slope ADC. Again, same question. I mean, for dual slope only, not DC. DC. बोर्ड चाहिए. Check your board. Asif, Mohan, Deep, Harsh, Aditya, Matthews, Nishita, Ruchita, Abhinay, Vasista. Okay. So what is the dual slope ADC response very fast is always wrong. So it requires better. It is having better accuracy. So it requires a stable source. Source to chahiye reference voltage should be a constant value. Okay. So you can also say one is not correct. Okay, you can choose both of them. One is not correct is true, but one is not correct is saying four is true. It is like a aptitude. Okay, four is not true now. So in that available, we should check two. One is not correct. Okay. Okay. So next, see this question. He has given 12 bit, 1 microsecond. So what is the answer? 14 microseconds. So what is the T conversion? I'm not conducting here poll intentionally for this question. 14. That is n plus 2. Here the ADC must be okay. What is the ADC he asked? Here two possibilities are there. Two possibilities are there. A 12-bit ADC operating at 1 microsecond, total conversion time is 12. The ADC must be. You can say SAR, but this is also not wrong because depending on the input, total conversion time he said, na, not for specific input, then only this. If he gives for specific input, this is also correct. Okay, but he said total conversion. That is for any case. For any case, we should take SAR. Next. Last question for you. In this, there is a mistake. I think Aditya, your doubt also came here. In a SAR type ADC, offset of half LSB is added to the D2A output. Actually, it should be subtracted. Yesterday class I told that. Okay, your input is equal to 2. Okay, so here step size is equal to 1, for example. First 1,000 is there. Then this is 8 volts. Okay, so actually if you take it as a 2, 8 is less than or equal to, sorry, input is, what is the input? 2 less than or equal to 8 also. So 0, 1, 0, 0. It is 2 is less than or equal to 4 also. 0, 0, 1, 0. Then also what is that? 2 less than or equal to 2 also. 0, 0, 0, 1. 2 greater than 1. It is 0, 0, 0. This is what it will do. But what I want is, it is a 4 volt. It is a 2 volt. It is 1 volt. What I am saying is, if instead of 2, if it is made as 1.9, if it is made as 3.9, if it is made as 7.9, 0.9, what is the advantage? It is 7.5 you take. Okay, 3.5 you take, 1.5 you take, and 0.5 you take for comparison. In that case, what happens is, to here 2 is greater than 1.5, so you will be having 0, 0, 1, 1. Okay, that is what is that? 3, say 2.5. So 2 less than 2.5. You will settle at 0, 0, 1, 0. I'm sorry for this area availability. You understand this? So green color and red color logic, it is the original. Okay, but what I did is I just made subtraction of half step size. Okay, I have added minus half LSB. In that case, advantage is if you give 2, you get the answer as 2. Okay, you can also do like this. Instead of taking 2 as the input, you take 1.5 as the input, subtract it and try it. Like that also you can. Sorry, you can add 0.5 at the input, or you can subtract 0.5 at the DSP. That part, that is the point I told in the last lecture, last part. Okay. Here there is no, actually it should add step size of half LSB is minus half LSB. In that case, it will reduce the quantization. Maximum quantization. Worst case possibility. Okay, that's all for today. For what? Poll. That's all for today for poll. Wait. I want to some long period. I am not able to give you what is that. Some people have dedicated hats for them. Sainath, Bhuvan, Harsh. From long back, I am not able to thank you. Deepak, Vishwajit, Yuvraj, Debaran, Insta, Kumar, Shubham, Vishal, LPSR, Shalem, Akshat, Jyotismayi, Deba Jyoti, Dubey, Shubhankar, Kumar, Tanya, Dubey, Sriram, Rudraksh. Thank you very much for your all hat dedications. Okay. Thank you, Deep. What happened? 1 minute. Aditya, any other doubts? 180C is free for everyone. Thank you. DBP chahiye to I can provide tomorrow. Actually, I need to get it typed. Some micro because of I'm getting it typed for microprocessor. I will try tomorrow. How negative edge is simple. All ones. Okay, then it will count. In this case, only negative edge, not every case. If it is something else, we can accordingly. Notes I will upload in the group. Don't worry. The, this is only for this case. We can take it as a negative edge triggering. Okay. If you are designing for something else, it may be something else according. Okay. Accordingly, we will design it. If you want it, whenever you may use the some decoding circuit. Whenever 10 comes, it should give clear like a counter design. Design is in your hands. After that, class is common, na? So August up to 10th, I think. August 8th. Rutik is having some question. Rutik, further you wait. A 8-bit digital RAM type ADC is having a resolution of, okay, clock frequency, the comparator with a threshold voltage of 1 millivolt. What is the meaning of threshold voltage is normally we are taking V in greater than something, V1 greater than V2, it is giving the output equal to 1. But here it should be minimum greater by 1 millivolt. Then the digital output is 6 volts. Okay. For the 6 volts is, what is your doubt? That is added by examiner. Why it is added means why are you asking me? Ideal case, actually in the ideal case, op-amp will not have any threshold edge. Practically it will have threshold. Okay, if V1 is simply greater than V2, it may not give you 1. It should be greater than V2 by some minimum voltage, then only it will give you. That is added in the question. That I told also in the class. Okay, ideally this is the condition, practically threshold will be there. Anything else? Thank you, good night. In fact, in the network, yes, I made it. So networks from August 3rd. Anyway, after 2 days you will be coming, we'll discuss. Thank you, Asif. Good night. Bye bye.